Earth is dying, my friend. See the images you also must be experiencing from day on day out. What is happening? We are responsible for what we do in day and day's life. Let us look at what are the reasons. Hello friends, my name is Ajaz Kazi and I welcome to my YouTube channel. The topic, as I said earlier, is on the decarbonization. Is it a real problem? Many of us must be facing these issues across the globe. Is decarbonization is a real problem? Let's see, is it a problem or no? Do you know 40% of global energy is consumed by the buildings? Buildings which we live, buildings which we go for offices, which is amounting to 33% of greenhouse gas emissions. See the buildings, 40% of global energy. You can just see, and I and many of you who are part of this building construction industry are very much responsible for the images which I showed you before. See, the buildings are rising, mountains are getting cut, forests are getting cut, and we are becoming more and more urbanized. The green cover is getting reduced, right? So this is the first information, the first piece of information which I wanted to give. Let's look at forward. In the COP23 meetings where all over the world's countries gathered in Dubai, they talked about controlling the temperatures. They talked about that we can control the temperatures by the end of the century to 1.5 degree, right? This is the major decision taken, bold decision, very difficult goal to achieve. But if you look at what is happening till now, to achieve that we need huge amount of cuts in emissions. If you go like this, it is going to go beyond 4 degree. And if that happens, many of the countries will not be there. So future temperatures, and this is one of the slide from the source which is mentioned over here. Very important situation we are in. Temperature rise. The average rise is 1.81. You can see all of these countries who are here, everywhere the issue of temperature rise is happening. As I said, we are part of energy, we are part of construction sector, we are part of HVAC teams, and you can see HVAC system is energy guzzler. Close to 50 to 60% of commercial buildings energy is consumed by HVAC. So we need to act very responsibly, right? And this is what you must be hearing so many now vocabularies of words: decarbonization, 5-star rating, energy efficiency, indoor air quality, climate change. These are some of the things. But let us look at what we can do, little basic things in what we do in our life, because we might get lost in these terminologies and might forget. Yes, these are important terminologies, we have to move with them, but we should not lose our focus from the fundamentals and the basics. Let us look at, when I talk about HVAC, the design comes first. System calculations, the heat load calculations. Most of the time we find we go on adding safety, just become complacent, just want to remain in comfort zone, and we oversize the system capacity. That is dangerous, right? Because they will not work with the optimum efficiencies. Selection of equipments, understanding the application, and then the selection of equipment, or just go on selling what you have, is another important point in HVAC design. Design of low side system, because generally we look at the high side system, HVAC chillers, higher COP, fantastic. Pumps, IE5 motors, very good. What about ducting? What about piping? These are also important things in HVAC systems. When I talk about centralized HVAC system, when I talk about VRF systems, the piping designs also need attention. Most important thing which I feel is the integration of system components, because in HVAC it's not a one product that gives you cooling. Talk about large buildings, HVAC has so many systems. You have chillers, you have pumps, your control system, your ducting, your pipes, and a lot of control systems, valves, they are working. If they work in isolation, your system efficiency will be much lower. They have to be integrated. They have to talk to each other. Once that happens, your system efficiency will be much higher. And that's another important point when I talk about HVAC design. Selection of optimum as well as the simple design, because finally these plants have to be operated by operators. We can't give them the complicated system. We have to be user-friendly systems. It can give us pat on the back that I have decided I have made a very complex system, but that is not what we need. And just to add on the integration, the building management system have to be in place, and most importantly, it has to be operational. I have seen sites where most of the building management systems are installed, but they finally don't end up giving the same benefit which is supposed to be given. So these are some of the things which I thought are part of design, where we start with HVAC design. This is one of the building which I got a research paper on, and the source is here. This is the building in UAE which has used a very good systems, because UAE, the temperature in the night in most of the time of the year are lower. What they do, you can see over here, they pump in the night fresh air, outside fresh air, which is much cooler. You can see over here, and they take it up because warmer air goes up. In the same process, they cool the entire building structure. What happens? Your building base is already cool, so you don't have to cool more. Your capacity of the system can be properly utilized. Your efficiency of the system can be higher. Because your base is getting cooled in the night, you don't have to run the air conditioning system at highest peak capacity. Much of is already done. System can be operated with lower capacities. Your efficiencies can go up. In the same time, you can see the sunlight which is required, the louvers which is specially designed, they will work with the sun path. So whenever you need lights, you will get lights, but you don't get direct radiation of the sun. So your internal heat is reduced. Another important thing about this building is they have created a building envelope within the envelope. So there is external envelope and there is an insulated internal envelope. You can see from outside the outer part, but by doing this, by adding a cabinet or by adding an insulated box within the building, you actually reduce a lot of external load. Our effort should not be on only calculation of the heat load. The effort should be how do I reduce the heat load, and this is where collaboratively we can work with the architects, with the developer, with the owner, that how do I reduce the capacity of air conditioning system, otherwise it will become an energy guzzler. One of the important things which I thought I will be able to share with you. If the systems are designed properly, not installed and not commissioned, it will have again consequences on energy efficiency, energy consumption. So it's very important that we should get the design done, install it accordingly, and then commissioned is also accordingly. But there will be some gaps which needs to be filled up, but if you don't commission, we will not know what are those gaps, right? So it's another important thing which I thought. But look at this. This is the installation, which I have seen one of the things. This is not what we need, right? So when I talk about air-cooled chillers, when you install multiple chillers, you must see the gaps between the two chillers. If the gaps is lower, your machines is not going to work efficiently. If the distance between the building facade or building wall and the chiller is less, it is not going to work efficiently, though your chiller is most efficient. But if you don't install it, these are some of the things you can see over here. Building and the chiller gap, when you move out, it becomes better and better. This is, as I said, about in between chillers. When we have a larger gap, it works properly. So air-cooled chillers, which are very important for design, we must look at what is the load profile, what is the system requirements, what is the climate, and do the design or selection of the air-cooled chillers. You should know what is going to be your optimal load based on the load profile. what is the chiller's optimum efficiency, because it is not, there's only range in which chiller will be most efficient, not all the capacities or not all the percentage loading. You have to match your design load profile, design band of or heat load, and the design or optimum efficiency of chiller, both have to match. Otherwise, best of COP chillers, which will be working at the peak capacity, but that will not work for the most of the time, will not yield you more results. You have to see what is the band in which the chiller works efficiently. If it works for maximum period of time in the year, you are bound to get a better efficiencies, right? So you should know the efficiency band of the chillers. You should know, as I said, the load of the chillers, and you should not only look at the chillers, look at the plant layout, because efficiency will also depend on how your pumps, how your piping is done. If pipes are like this, again it will have an impact on the overall plant efficiency. So you also must look at the layouts. Let's look at, here you can see a chiller installed. Look at the gap over here, very less. Yeah, these are some of the photographs. So we have to look at, when we install, avoid airflow recirculation. The air should not come back again and again. Make sure there are no obstacles in the airflow, and make sure that the air chillers are not installed in a dusty environment, which will again impact the heat transfer. When it comes to operation and maintenance, again tracking the parameters, because your design profile may not be exactly same. When we operate for a certain period of time, you can get a best efficiency data. Then you can match the load profile actual efficiency of the chillers, operate the chillers for its most optimum efficiency most of the time. Adjusting the chiller parameters, you have to change maybe set points, see that chillers are in good efficiency range. Regular maintenance, cleanliness, water quality, these are some of the things which are required when it comes to our chillers, right? So when I got a bank of chillers already installed, how do I make them more efficient? You have to look at whether I can do a retrofit of compressor, but you need to check the compatibility. For everything which I'm going to tell you now with respect to retrofit, you have to look at this retrofit compatibility. You can add the compressor VFD, which will give a variation. You can change the set points. This you can do without even looking at the compatibility point. If you make it from 6 to 7, you get huge benefit in efficiency. You can talk about condenser or evaporator cleaning. Again, there is a good chance of getting more efficiency. You can, again, based on the compatibility, thermal expansion valves can also yield you good saving. And if you have air-cooled chillers, if you upgrade the fans, again with the compatibility point of view, to EC fans, you will get saving. Then the saving percentage, approximate percentage, which you can get from the retrofitting of the air-cooled chillers. The next one is you can add the pre-cooling or free cooling. Add economizer at the inlet of the condenser coils. Get pre-cooled the air entering, which is hitting the condenser coil before it hits. You get a good saving of 20 to 25%. This is how they're done. You can see a jackets over here. Hot air comes. If it is 45 degree, gets cooled to 25 degree, which enters. Finally, you can get a better heat transfer, better efficiency. This is how they are used. And there are many types. I'm just giving some of the examples of getting the pre-cooling before it hits to the condenser coils. So these are with respect to operation and maintenance. Let's look at one important aspect is VRF. I'm just taking a couple of pieces of system. VRF. We have to first understand what is the application. Don't go on ceiling because it saves the height of the false ceiling. See how you are selecting the indoor of VRF. If you select at a very, very low velocity speed, you will again end up in using higher capacity. Look at it, the medium speed. If noise is not a major issue, go for higher speed, right? But layout becomes an important aspect. Yeah, if you add the system, or even if the split system or VRF system, and add a ceiling fan, I'll show you how it impacts with the energy efficiency. See how the outer location is, because again it is similar to air-cooled chillers. If it is not properly done, you will have even VRF will not be more efficient. This is what talk about the fan with the AC. You can see the air temperature 25, 26 degrees the cooling, find set points 23. You get a feel like temperature of 23 even if you set the AC at 26 degree with a fan at this velocity or this speed. But if you only put AC and do every entire envelope at 23 degree, you can see what is the difference between the energy. 1.8 watt per meter square to 2.8 watt meter square. So just adding one simple fan can help, right? Use of low noise ceiling fan. These are available, right? When it comes to installation, make sure that again, no obstacle to airflow. Surrounding is clean. Always follow the manufacturer guidelines. Look at these guidelines, some of these, but you can see how they are being installed. This is not the way. These are the connection of IDUs to the ducts, not done properly. See, there are manufacturers which use a proper guidelines. Follow those guidelines. Otherwise, you can see over here, you put a staircase on top of the top discharge VRF, and you have problems later. When it comes to operation maintenance, again, setting of thermostat, scheduling of operations, cleanliness, an important aspect. Look at how clean they are. They will work much better, much efficient, right? Regular cleaning of the coils, and again, regular cleaning of filters and the indoor units. Very important. If they get chopped, you will have impact. These are some of the basic things, as I said, which are required to be done by all of us. Refrigerant leak can be a major issue with the VR because everywhere the refrigerant flows, and if that goes out, greenhouse gas emissions which comes into play. Cooling tower, again, it needs a proper air circulation. You can see over here, otherwise wall is very close to cooling tower. Look at this starvation of air. Cooling tower will not work efficiently, and recirculation will actually not help. Fans, even for the fans, follow these guidelines, because when you connect, and if your turbulence like these over here, you will not get the best efficiency of fans. Your axial fans, look at the correct, incorrect way. It will directly have impact on the ducting low side. Look at this. With this, you will not be able to get the airflow which is required. This is not the way to install, and this is where we face major issues. Piping, you can see the bends over here. Immediately after the chiller, it will have issues. So these are some of the things. Insulation, not insulated properly, huge issue on the energy consumption. They have to be installed properly. Otherwise, you can see total sweating over here. It not only sweats, but it also adds to the energy consumption. Some of these photographs of insulation over here. Duct insulation. So look at the way it is done, properly done, but we find there are issues. When it comes to commissioning, the reality is here. We must get our people trained. Otherwise, it will show you his own body temperature, which is not a real temperature. So we must look at how do we commission the system, how do we have building automation system, how we can get the HVAC and building automation system integrated so that we monitor the status, sensors, control the devices, schedule the set points, get the trains which can be input to us, which will help to optimize the energy efficiency. And when I talked about operation maintenance, always the goal has to be first energy efficiency, increase the lifespan of this equipment, because that also helps in the circular economy. Again, is an important aspect. Indoor air quality, which will lead to cost saving. Some of the operation guidelines, proper temperature and humidity control, setting of thermostat schedules, which we can easily done now with the technologies. How do we optimize the airflow, and how do I don't overload the system, because that will again work with more and more energy consumption. Some of the routine maintenance, cleaning the filters, refrigerant leaking, see the gland is leaking, cleaning of the strainers, very important. Again, it will add the energy consumption of pumps otherwise. Belt tension checking, again it will lead to energy consumption. Routine maintenance of cooling towers, look at the left hand side pictures, right hand side picture, all are related to energy consumption. routine maintenance of condenser coils, and then get the data, analyze the data, take corrective action, because it's a continual improvement process. It cannot be done once and then forget. No, you have to be at it. How do we maintain the water quality? Get the water quality criteria from the manufacturers. One of the sample sheet is here. Again, important aspects. So these are some of the best practices for operation and maintenance. Yes, have to be done. There is a lot of knowledge, but we must implement it. Look at this. And awareness. As I said earlier, the awareness has to go to the bottom of the pyramid. Plant operator, he should know what is the major issue. He should be aware of what is the problem we are going through. What is the problem of the world, of improving, of the climate change, the temperature rise, the efficiency improvement which is required. If he is not known, it will not, because we must first of all put the purpose and the goal in the minds of operator. Then they will get and operate system efficiently. This has to go. It's our responsibility to spread and educate, and this is one of the simple or one of the very tiny step which I am taking by putting this video on the YouTube channel. Human behavior is again an impact. So not only us, but we must also take the public, because building occupants who occupy the building, they also should know the concern, right, about the energy efficiency. Because the human behavior, because if we start satisfying everybody's need of temperature and humidity control, it is going to be not possible. We must tell them, we must display probably what is the energy consumption data of your office, what is the benchmark. This will slowly even educate them. Use of stairs, don't take the lifts. Use of ACs with proper temperature control. Get more natural lighting. These are some of the things which we must push. Switch off when not required. The stairs are not only for fire exit or to smoke. We can always use stairs. We look most of the time the left hand side image of our staircases. We have to get more people in using the staircase, because every tiny step which you take will help. One of the example which I have seen in one of the government public sector unit, they display the food wastage in a canteen and in a bold indicator. This actually sends a signal to the people who are eating, don't take more food and don't waste your food. Similarly, can we have, as I said, energy consumption data? What is the benchmark and what is this? This will set the ball rolling. We have to take the entire community together. We can't do it alone. So it's very important that we provide the messages which actually becomes a trigger for everybody to start thinking about this problem, right? Even choice of clothing. This is another important. We are not in Europe, which we can go always with, suits and blazers. You will need more cooling temperature there. So choice of clothing based on the climate is again an important part. Display, as I said, the power consumption versus benchmark. We must walk the talk and lead the example, because if you go on only giving GAN or knowledge and not practicing, will not help, because people follow us. Let us understand there is a problem, right? The problem is genuine. For us and for future generation, it is our responsibility that we don't leave them a bad environment to live in. We have to be creating an environment in which this young, people's smiles remain for a long period of time. They have to also live in the cleanest environment. It's our responsibility. They are not doing anything wrong. It is the way we are working will actually affect them. So it's very important to make sure that we leave the legacy by becoming a responsible citizen, responsible human being. So there's a hope, and I'm sure you have to start with us, right? Use of shower versus water leakages. These are some of the things, and this is where we can see what are the category of behaviors and how can we work. Some of the examples over here. I'm leaving this slide with you, which is very self-explanatory of behaving responsibly, so that we leave that world, planet for our future generations to live. Thank you very much for your patient listening. This is an announcement over here of a course which I said, if the system is designed well but not installed properly, it will not give a good energy efficient system. So this is the course which will talk about good installation practices in HVAC system. The link is in the description box. Just click the link and take full benefit. Please subscribe my channel, and if you have liked this video, please spread it. Give your comments, share your comments, because let us not be a one-way traffic. I will be very happy to receive your comments, good comments, critics, all are welcome. Please send in your comments, subscribe my channel, follow me on YouTube, Facebook, LinkedIn, and ajazkazi.com. Thank you very much.